to Max lecture series. In this series, we are learning how to obtain the solutions for differential equations. So, from today lectures onwards, we are going to learn how to obtain the solutions for higher order differential equation. If you observe, we understood how to obtain the solution for first order differential equation, only first order. Higher order in the sense, degree of d should be more than 1, like 2, 3, 4, 5. If you observe the given differential equation, what is the highest order? Highest order can be found by observing the highest power of d. So, differential equation highest order is 2. So, if the order is more than 1, then how to bring the solution? That is what we are going to learn from this lecture onwards. Here some example given. Before looking into the solution for the given question, let me tell you, in case of higher order differential equation, we will be having two types of solution. While obtaining the complete solution of a function, sir, how to write down this? If you observe, even in first order differential equation also, it will be written like this, dy by dx. Just for an example, I am taking dy by dx. The numerator variable is called dependent variable, denominator variable is called independent variable. So, solution for this function can be written as dependent variable is depending on independent variable y of x, that is the solution, equal to we will be writing the final answer. Yes or no? In the same fashion, for higher order differential equation also, see here, if you observe, numerator is y, that is called a dependent variable. Denominator is x, that is called independent variable. Now, what we have to do, the solution. Dependent variable is depending on independent variable. So, y of x equal to, if the order is more than 1, then we will be having two solutions. One is called complementary function and another one is called particular integration. Okay, sir. Now, what we are going to learn is, first we are going to learn how to obtain this complementary function. Later we will be learning how to obtain the particular integration. Remember one thing, complementary function, the solution of complementary function can be directly obtained from the LHS, left hand side of the differential equation. Whereas, the solution for the particular integration can be obtained by combining RHS and LHS. Do you understand anything? In any given equation, if you observe, we will be having two sides. Even if you observe the given equation also, we will be having two sides. Yes or no? One is left hand side, another one is right hand side. Which one is left hand side here? The one, this equation. This is left hand side, whole equation. On the right hand side, we are having 0. So, by combining right hand side divided by left hand side, we are going to bring the solution for particular integration. Now, you have to ask, sir, already this right hand side value is 0, sir. If the right hand side value is 0, then particular integration will become 0. Why? Because I told particular integration can be obtained only by considering right hand side divided by some key terms from the left hand side. Later you will be understanding that. When right hand side is 0, then automatically particular integration will going to be 0. Then the complete solution for the given differential equation is only complementary function. Okay. Anyway, later we will be bringing a few more terms on the right hand side. We will see how to bring the solutions and how to obtain the particular integration. From this lecture onwards, we will be focusing on higher order differential equation, and first we will be learning how to obtain the complementary function. Okay, fine, sir. Now the question is, the given question is d square y by dx square plus 5 times of dy by dx plus 6y equal to 0. Obtain the complete solution for the given function. So, complete solution, first you have to observe the numerator, we have y, in the denominator we have x. So, it can be written as y of x. We know numerator means dependent variable, denominator means independent variable. We have to write dependent variable is depending on independent variable y of x. We should write like this, equal to only complementary function. After that, sir, how to obtain the solution? It is very easy. Whenever you are requested to obtain the complementary function of a higher order differential equation, what you have to do is step number 1. Just observe here. If you have d by dx, just replace d by dx by capital D. Similarly, if you have d square by dx square, replace it by capital D square, this one. Similarly, if you have d power 3 by dx cube, replace it by d power 3. In the same fashion, if you have higher order variables, you can replace it by d power 4, d power 5 and so on. That is the step number 1. So here, if I will replace this d square by dx square, I will be getting, see there, this total term will be replaced by d power 2. So d power 2 into y plus 5 into d by dx will be replaced by capital D. So it will become 5dy plus 6y. Can I write this equation now like this? See there, d square y plus 5 times of dy plus 6y equal to 0. What I did, I have replaced just this d square by dx square by d square, capital D square. Similarly, d by dx has been replaced by capital D. That's all. After that, after doing this step, immediately you can observe that this dependent variable will be existing common to all. So you can take it out. If you take this dependent variable outside, y is called a dependent variable. I told always in differential equation, if you can observe two variables, one is in the numerator, another one is in the denominator. The variable which is lies in the numerator is called a dependent variable. The variable which is lies in the denominator is called independent variable. So after observing this, what you have to do? You have to keep in this format. Dependent variable is actually depending on independent variable. Write the solution like this. Okay, let us carry on. So here you can observe, after replacing d by dx, d square by dx square by d square, you can observe this dependent variable will become common in all places. So take it out. After taking the dependent variable outside, you can observe one polynomial equation here. So take this polynomial equation outside, just equate it to 0. Like what you have to do is d square plus 5 times of d plus 6 will be equated to 0. Hereafter, try to obtain the solution for this. D square plus 5d plus 6 equal to 0. It means you can break these roots. This is called characteristic equation. This polynomial equation is also called characteristic equation. By resolving it, you can obtain the values for d. That is simply called roots. Roots means what we can say, d square plus 5d plus 6 will become 0. This can also be rewritten as d plus 2 plus d plus 3 equal to 0. If you once again do the product, inner multiplication, you will be obtaining the same expression. Now see there, how can I resolve this roots? How can I resolve this characteristic equation to obtain the roots? Here we have 6. So it is indicate product of two roots will be 6. Here we have 5. Addition of two roots will be giving 5. See there, I have selected 2 and 3 here. We know basically we will be using our common sense to obtain the roots for second order differential equations here. So basically we will be going up with this method, or we can also use that quadratic equation formula, minus b plus or minus. We know when an equation is existing in this format, a times of d square plus b times of d plus c equal to 0. Then the formula to obtain the roots of d, minus b plus or minus square root of b square minus 4ac upon 2 times of a. So here you can substitute, coefficient of d square will become a, coefficient of d will become b, constant will be c. By substituting all the variables here, you will be getting 2 roots. In that way also you can obtain these roots. Okay sir. So after obtaining the roots, here I am getting plus 2 plus 3 only. So I am writing d plus 2, d plus 3. From this I can say, since they are equal to 0, so if I am equating to 0, then d will give you minus 2, here this d will give us minus 3. So we obtain 2 roots from the given differential equation. So whenever you are requested to obtain the complementary function, step number 1, replace d by dx by d, d square by dx square by d square and so on. After that you will be getting one characteristic equation with a common dependent variable. Take the dependent variable outside, equate the characteristic equation to 0, obtain the correspondent roots. Once you obtain the correspondent root, then it's time to write down the complementary function. See there, I came to the final step. Sir, how to write down the complementary function? We know, as we saw, y is lies in the numerator, that is called dependent variable. X is lies in the denominator, that is called independent variable. So the solution can be written as dependent variable is depending on independent variable x. So y of x equal to, we have only complementary function. As I told you that when the order will go more than one, we will be having two solution. Complete solution can be written as the addition of complementary function plus particular integration. So particular integration will be always 0 when the right hand side of the characteristic, when the right hand side of the equation will become 0. So here the right hand side of the equation is 0, so particular integration will not exist, only we will be having complementary function. Sir, how to write down the solution? Now it's time to observe the property. After finding the roots, you are observing that, sir, roots are purely real. Real means there is no imaginary part, we will be having only real values. It may be positive or negative, but they are real and they are different. Different mean what? -2 and -3 are different values. Same value means 3, 3 are same value, 1, 1 are same value, 10, 10 are same value, -10, -10 are same value. They are called same values. If you observe here, we are not observing same values here, here the values are different. That is called distinct. When the roots are distinct, what you have to do is observe how many roots that you are having here. So we have only 2 roots. So if you are having 2 roots, then step number 1, write down 2 arbitrary constant here. In addition, you have to write down 2 arbitrary constant in addition. After that, multiply it by exponential factor e. Then go to the power of the exponential factor, write down the roots values directly. Root value is -2, -3. After that, multiply it by independent variable. See, already we know in our equation independent variable is x. So just multiply it by the independent variable. That is going to be your complementary function or complete solution for the given equation. So in this session, we understand how to obtain the complementary function when the roots are different. So in the next lecture, if the roots are same, sir, they are real only. If they are same, then how to write down the solution? So let me give one example. You can try it by yourself. Later, you can observe the solution in the next lecture. I am writing here d square x upon dt square plus 6 times of dx by dt plus 9 times of x equal to 0. That is the given differential equation. Now tell me whether the particular integration will be existing for this or not. If only complementary function will exist, then how to write down the solution for that? This is all for this lecture. In the next lecture, we will be coming up with a solution for this given equation. Thank you all.